In this video, we will be evaluating definite integrals. And so on this first example, you'll notice that we are being asked to evaluate this function, negative 3 over the cube root of x, from the interval where x starts at negative 1 and ends at 2. And so remember, when you are integrating something like this, the first thing that I would do is I would rewrite this in rational form instead of leaving it in radical form. And so the cube root of x would be the same as x to the 1/3 power, but because it's located in the bottom of a fraction, it would have a negative 1/3 power. Okay, so now we will apply our rules of integration. So negative 3 is just a constant. And so remember that we're going to add 1 to the power. So we're going to have a negative 1/3 plus 1, and I'm going to think of that 1 as a 3 over 3. So that gives us our new power, which would become 2 over 3. And then we divide by that new power, which would be 2/3. Now normally we say plus a c, but since they have given us a interval, we don't have to add the constant because we're just evaluating on that particular interval. And so once we simplify this, we will be plugging in values that go from x equals 1 up to x equals 2. So now let me go ahead and simplify this. When you are dividing by a fraction, it's the same as multiplying by the reciprocal. So we're going to be multiplying by 3 over 2. That gets it off the bottom. And so in simplest forms, negative 3 times 3 over 2 would give me a negative 9 over 2. And then we have our x to the 2/3 power. And again, we are evaluating that from 1 to 2. So you actually are going to plug in the top number first. So we'll have our negative 9/2. And we're going to plug in the 2. So that'll be 2 to the 2/3 power. And then we are subtracting a negative 9/2 times our x value of 1 to the 2/3 power. Okay, so when we actually go and simplify this, they're going to put the answer back in radical form. So I'm just going to leave the negative 9 over 2 like this. Remember that the number on bottom tells you what root we're dealing with. So that would become a cube root. And then if you apply the power on top to the 2, 2 squared would give you a 4. So negative 9 cube roots of 4 over 2. And then when we simplify this, when you have minus a negative, that becomes plus a positive. 1 to any power is still 1, times your 9 over halves would just be plus 9 over 2. They ask us to give it in exact form, so that would be your exact form answer. And then they also ask me to round it to 2 decimal places. So when I get on a calculator and I actually punch it out, I'm going to get a negative 2.64, round it to 2 decimal places. Okay, so on this next one, again, we will evaluate the integral first, and then we're plugging in, or we're looking at the interval from 8 to 17 on our x's. So remember, when you have, you can think of this, so the integral from 8 to 17, 2 is just a constant. And technically, if you wanted, you could pull it out here. So what we're really evaluating is the integral of 1 over x. And so if you remember, think about your derivative rules. It is the natural log of x that gives you 1 over x. So when we integrate, though, we say it's the natural log of the absolute value of x. Now, you cannot forget the 2 that was out in front. And again, we are evaluating that from 8 to 17. And so when we plug in those values, come down here, we're going to plug in the 17 first. You get the natural log of the absolute value of 17. And then we say minus, and then we have a 2 times the natural log of the absolute value of 8. And so, of course, the absolute value of 17 would be 17, and the absolute value of 8 would be 8. The last thing they're going to do is they're going to use our properties of logarithms, and what we learned with properties of logarithms is that if you have two logarithms that are being subtracted, you can actually make a quotient out of these terms. So they both have a 2, and then we can make a quotient out of the fact that the 17 would go on top and the 8 would go on bottom. And so that would be an exact form answer that they're looking for. And then if we got on our calculator and punched it out, we would have the decimal that would be 1 point, and of course that's approximately, it's not exact, 1.51. Okay, so on this last one, you'll have to recall the U-substitution that we did. So in this case, I would let my u be equal to the higher power of x, which is the 3x squared minus 1. And so then in that case, the derivative of my u would be a 6x dx. Now you'll notice we don't have a 6x dx in here. We have a 12x, so we can easily fix that. We would have to multiply by 2 to make that a 12x dx, and so that would make that a 2 du. So now when we go into substitute, this is my u right here, so that would be u to the third. And then in place of the 12x dx, based on what we have here, we are putting in a 2 du. Now, since I went ahead and changed to u, you're going to also want to change your interval, because remember, these are x values. And if we're going to work in u, we need u values. So if I take my x value of -1 and I plug it into my u, I would have a 3 times -1 squared minus 1. So my u would be 3 times -1 squared is 1, 3 times 1 is 3, and minus 1 would leave me with a 2. So this bottom number would be a 2. And then if I take the x equal 3 from the top and I plug it in, I'm going to have u is equal to 3 times 3 squared minus 1. So my u would be 3 times 9 minus 1. So 3 times 9 is 27, minus 1 would leave me with 26. So that upper number would be a 26. Okay, so now we are ready to integrate. Remember, the 2 is just a constant, so we can just pull it out to the front. We're going to add 1 to the power, so 3 plus 1 would give us a 4, and then we divide by that new power of 4. And then, of course, we're evaluating from the endpoints of 2 to 26. Now, if you want to go ahead and reduce this first, the 2 over 4 would just become 1 over 2. And then as we plug in, we're going to plug in the 26 first. You're going to get 26 to the 4th power divided by 2. And then we have minus 2 to the 4th power divided by 2. And so if we go ahead and evaluate that out completely for our exact form, 26 to the 4th power is going to be 456,976. 2 to the 4th power is 16. And then if I divide by 2, I get 228,488 minus 8. And so that will leave me with 228,480. So since that is the exact answer, it says or round it to 2 decimals. Obviously that answer does not have 2 decimals.